There are a couple of skills I always wish my students were better at. One is fluency with their multiplication facts, and one is their fluency with fractions. So today we want to show you a couple of activities that should help them conquer both of those obstacles. Once those two columns are finished, I ask my students, what's going to be the most challenging set of facts to remember? And they say the 12s. And I say, really? The 12s should be easy because of the trick. And they go, what trick? And I said, oh, you don't know the 12s trick? It's very simple. For 1 times 12, it's right in front of our face, 12. For 2 times 12, it's 24. If you know your 1s and 2s, you know your 12s. 3 times 12, 36. 4 times 12, 48. And then I tell them 5 times 12 is 510. And they say, well, that can't be right. I'll bet it's 60. Put down the 0 and add the 5 and the 1. Put down the 2, add the 6 and the 1 to get a 72 for 6 times 12. 7 times 12 is 84. 8 times 12 is 96. 9 times 12 is 108. 10 times 12 is 10 plus 2 is 12, and a 0, 120. 11 times 12 is 11 plus 2 is 13, with a 2 after it. And lastly, we have 12 and 2 is 14, with a 4 after it, 4. 12 times 12. The 12s are very easy if you know your 1s and your 2s. Let's solve another problem on our multiplication table. Now we're going to solve a proportion. Here we have 6 over x is equal to 14 over 63. You know what I like about proportions? You can draw rectangles around them. What's the big deal about rectangles? Well, they have 4 corners. And if you look at it, we have numbers in 3 of those corners. We have a 6 next to a 14 and a 14 over a 63. We need to see if we can find that same arrangement of numbers in our multiplication table. And it turns out we can. There are lots of 6's, but I want the 6 that is next to a 14. And a 14 that is over a 63. But look at the missing corner of the rectangle, and we find the number 27, which turns out to be the answer to our problem. Students are amazed that that trick works, and they want to know if it always works. I say, well, of course it always works. It's not rocket science, because what is that 6? That 6 is a 2 times a 3. And what is the 14? It's a 2 times a 7. And what is the 63? It's a 9 times a 7. And what is a 27? Why, it's simply a 9 times a 3. And at this point, we could actually solve this a couple of ways. Cross products tells us that 2 times 3 times 9 times 7 is equal to 9 times 3 times 2 times 7. I'm multiplying the same digits in both cases, and the commutative property says we'll get the same answer. But I could also cancel out common factors, such as that 3 and that 7 pair, leaving me 2 ninths is equal to 2 ninths. So yes, this trick will always work for solving proportions off our multiplication grid.